Hello, this is Mike Oliver, and this presentation is my one vision of an enterprise architecture. It is not necessarily a template for every company to build their enterprise architecture in this way, and this is just the technical architecture. It doesn't include the data architecture and the business architecture that TOGAF would require. So, we start with a cloud-based enterprise integration layer. And I say cloud-based because, not because I want to do it on the public cloud, but because the cloud gives us the flexibility to have multiple virtual machines and to have a distributed architecture that can serve multiple users and even cell phones and mobile edge computing and things like that. So, what's in the enterprise integration layer? Well, first we have an enterprise service bus. And for a large organization that has multiple domains, I would recommend a federated ESB. A federated ESB will give you the flexibility to have solution domains that vary from the central architecture for the needs of that domain. And I'll get into a little bit more of that down the road. In addition to the enterprise service bus, we need a message broker that supports these protocols: AMQP, Kafka, and MQTT. Now, why do we need those protocols? Most enterprise service buses run on top of a message queuing system, and you would think that would be enough. But the reality is no one message queuing system supports all of these in the same way. So, what is AMQP? That is an advanced message queuing protocol, and that protocol can be distributed, and that protocol can be tailored more to a large-scale redundant architecture. Kafka is particularly well suited for things like log files, big data extractions, things that can be offline, sometime build up a queue and then sync up at some later time, not for real-time transactions. MQTT is the other way. MQTT is designed for the Internet of Things. So it's a lot of small transactional operations. And so it's better at that than Kafka, and Kafka is better at what it does than AMQP. Under that, or in addition to that, or maybe in some way complementary to that, is a in-memory data grid, an in-memory fabric, if you will, that has all of these features. It has a data grid for data virtualization. It has a compute grid that allows you to distribute compute resources, a service grid that services a number of different capabilities that are in line with a service-oriented architecture, streaming, Hadoop for big data, advanced clustering where you can actually have clustering across virtual machines, across physical data centers, a very useful feature. A file system that can be distributed again across virtual machines and across data centers. Messaging, which is complementary to the message broker with the three protocols I mentioned. Events, which can be then orchestrated so that you can have a network function virtualization and the orchestration of events on your network, as well as events that are data-based. And then data structures that go with the data grid and allow you to have a virtualized data store. So, taking this as our enterprise integration layer, we then have our providers. And our providers include our application databases, our server farms and virtual cloud, commercial off-the-shelf software, legacy software that we wrote a decade ago, special purpose databases like a configuration management database, a service registry, and a product catalog. Especially if you're having products that are sold as services or products that are sold in an e-commerce store. And then one of our providers is our own big data, and we may in fact decide to sell some of that, customer lists, profiles, and so forth. In addition to that, we have our consumers. We have our web pages, we have our partners, we have apps, and those apps can be developed by us or by our partners. We have cloud-based applications like Salesforce.com that we can then integrate into our environment. We have big data consumers, people that pay for access to our own big data. We have gadgets and broadband users that are accessing via the internet. And we have the Internet of Things, where we may have devices implanted in every aspect of our society, and they all talk back to us in some way. So how do these talk to these? They do it through our network layer. And the network layer should be a software-defined network with network function virtualization, network function virtual orchestration, and a number of the typical network interfaces for controlling the software-defined network and for controlling the access to users. And this particular example is tailored to a cell phone service provider. And of course, we'll have a firewall in that network for security. So then how do we organize our internals? We do that through a series of domains. And these are called solution domains or service domains. And these are designed in such a way that they have a domain ESB, and that doesn't necessarily is not a requirement, I should say, because you can have a solution domain that does not have an ESB. It doesn't need one, or it actually hurts the performance, something along those lines. We want to give freedom to our solutions architects to be able to build the solution any way they need to. But if they want to communicate to the outside world, if they want to communicate with other solution domains, they must do it across one of these transports. So that is the OSS domain. It's our operations support system, and it plugs into the integration layer and has access to every other component in that layer. So next we have our money-making domains. These are solutions that we have developed internally and are available to our customers, and they pay for access to those. And again, it can have its own domain ESB, it can be built on a set of virtual machines or containers, and that gives us the flexibility to be able to build the solution in the way that is required by that solution, but still adhere to the enterprise standards when we need to communicate to the outside world. Next, we have a public domain. This can be anything from a website with active content to some place, e-commerce system where consumers can connect and buy things. And this public domain would have its own solutions architecture, and it would be made up, again, of a domain ESB if necessary, but having virtual machines and containers that plug into this integration layer. Next, we have our BSS domain. This is the back-end support system. This is where our accounting systems run, our customer relationship management systems may run, and this would be largely commercial off-the-shelf software like SAP or Sugar CRM, and this domain also would have a domain ESB and run on a set of virtual machines or containers as appropriate. So for all of our domains, we build them in a standard way. They can run on virtual machines or containers, and they may or may not have a domain ESB. They will all communicate to the outside world using a standardized service contract and a compatible schema. It doesn't necessarily have to be the same schema as the enterprise, but it does have to be correlated. So that would support all of these kinds of typical web-facing applications, an API gateway so that people can consume the APIs of the enterprise, an API manager that allows you to decide what APIs to be published and what access controls are necessary and so forth, a developer portal where third-party developers can access those APIs, give it a try before you buy, test it, and maybe build an app that uses it. We have all of the web pages that a typical enterprise might have. Some are purely for advertising, some are for product information, maybe some are for fee kinds of services. And then interfaces to the cell phone world with SMS messaging or apps that we build and publish. Perhaps one of the most important areas is the security domain. We all know about WikiLeaks and Sony, and we all know that there are hackers out there that are trying to get in and find out information. So a firewall is an important aspect, but also there's the intrusion detection and the analysis and the prediction, if you will, for the vulnerability of internal systems. And a security domain that is plugged into this integration layer can do the best job at that. So we will design it and build it and populate it the same way we do our other solution domains, where we may have a domain ESB and it'll be built on top of virtual machines or containers as appropriate. So, to finish up, we have a series of these domain solution containers, if you will, and they are all built in a standardized way. They all communicate with each other in a standardized way, and this gives us the greatest flexibility and the greatest agility because we don't have to reinvent the wheel every time we turn around. And when security needs to look at the CRM system and determine if there is a vulnerability, it's going to be easy because it's designed in a standardized way. Now, this enterprise architecture is actually the way we communicate to our solutions architects how we want things to work together. It doesn't have to be my way or the highway. It can be part of a governance process where solutions architects can propose a new solution and design their solution the way it works best for the company. Yet, when they need to interact with the rest of the company, we need a standardized way of doing it. And if we do that, then we're going to get away from the rogue application that is running rampant inside, and if it gets hacked, it can take over the entire organization. So, thank you very much. I hope you've enjoyed this vision.